Hello, welcome to Wednesday's edition of Cracking the Cryptic, and you'll see that I'm faced with another of these blank Sudoku grids today. That is because Mark has constructed a puzzle, I believe, today, and he wants me to try it live on screen for you guys, you know, unseen. So I'm going to load up the link he sent me in just a moment. Two things to mention before that. We have uploaded a puzzle on Patreon for you guys. It's free, it's not behind the paywall, and this is a puzzle by the Indian constructor Prasanna Seshadri. Prasanna is, you know, a world-class solver as well as a world-class setter. Sets for gmpuzzles.com. Yeah, so just it should be a magnificent puzzle, and we have every intention of producing a video on it. So you may be saying, why is it on Patreon? Well, it has the longest rule set I've ever seen in a Sudoku. It combines 14 different Sudoku variations in one puzzle, and I don't think we're going to be able to put the rules on the right hand side of a video screen. So what I've decided to do is we've loaded it on Patreon. You guys can play it, you know, the link is there, all of the instructions are there, or you could just decide to read the rules at your own leisure, waiting for the video to come out, and I'll record a video over the coming days for the channel. So yeah, something a bit different, certainly something interesting over there on Patreon. Just click on the link under the video. What else? Big thanks to those of you who've tried to promote our video on the so-called Miracle Sudoku by Mitchell Lee. What a puzzle that was. You know, I'm still dreaming about it at night. It is just an incredible Sudoku puzzle. I think the video's up to about 130,000 views at the moment, and in my opinion it deserves to go much more viral than that. So if any of you do have ways of promoting it, then yeah, we'd be most grateful. Now let's talk about today. Mark's going to be back later, I think, with a sandwich arrow Sudoku. Now he's told me this is some sort of sandwich Sudoku I'm going to be trying here, so I've tried to leave a gap around the grid. Now, if I've got this wrong, this is going to be an almighty shank, because I'm going to launch the puzzle and then the clues outside the grid aren't going to fit on the screen. So I'm hoping that I've left enough room. How does sandwich Sudoku work? Well, this is there'll be some numbers outside the grid. Let's look at this column as an example. Let's imagine there's a number up here. What would this number be? So let me fill in some digits. Let's fill in some digits like that. So the numbers outside the grid are the sum of the cells sandwiched between the 1 and the 9 in the column or row. So if you look at down here, between the 1 and the 9, we have cells summing to 15. So this clue up here would have to be the number 15. And that's all there is to sandwich Sudoku. It is the most beautiful type of variant Sudoku. Our first app was Sandwich Sudoku, and yeah, I'm a big fan of it. And with that, let me try and launch this puzzle and see what on earth Mark has concocted. Here we go. Ah, okay, right. This makes a lot more sense now all of a sudden, because last night James Charles released a video on his YouTube channel in which he gave a shout out to Cracking the Cryptic.
I discovered this puzzle channel on YouTube called Cracking the Cryptic, and I have fallen in love with their videos. My absolute favorite pastime in the entire world is doing escape rooms, but since the world is obviously closed down, I'm not able to do them. So if you guys are fellow nerds like me and you love solving puzzles, I would definitely recommend checking out their channel.
For which, obviously, James, if you are watching this, we were most grateful. And yeah, it appears that Mark has made him a puzzle as a reward. So look at this. We've got sandwich clues. We've got M's in some of the sandwich clues. We've got James Charles in the grid. So presumably, what are we saying here? Are we saying these two cells are going to contain the same digit? These two cells will contain the same digit. So each one of James's letters... yeah, okay. Yeah, so there are 9 different digits or different letters in James Charles. So Mark has used these letters to indicate numbers in the grid. So S's are repeated as well. One thing in common between me and James Charles is that there is not a surname between the two of us. Now this is going to be great. Right, so let's have a look. If you want to have a go, click on the link under the video. With that, let's get cracking and see if we can solve James Charles's sandwich Sudoku. Right, here's the place to start, I imagine. The 35 clue. This is the most powerful clue in a sandwich Sudoku because it means that the 1s and the 9s have to be on the edge of the row. Why do they have to be on the edge of the row? Well, if you think about it, every row in a Sudoku will contain all of the digits from 1 to 9. Those digits, if you add them up, you get 45. So what's the maximum we could put between a 1 and a 9 in a row? Well, it's going to be 45 minus 1 minus 9 because they're not inside the sandwich. That equals 35. So that's why I know that these must be right on the edge. Now actually we've got... okay, so now there's an M, a cell that contains an M in the Sudoku, so we know this must be a number between 1 and 9, and we've got a sandwich clue. So this sandwich clue, which ordinarily could go up to 35 and could be a 0 indeed, it cannot be a 0 in this case. It must be a single digit number, and in fact it can't be a 1 because you can never have a 1 inside the sandwich because that would repeat the 1 in the row. If you had sort of 1 and you know, if you had that, so trying to make this the I don't know, the sandwich filling, that obviously just doesn't work. So actually we know, let's put my 1 9 back here. Where's the cursor gone? So we know that this must be positive and it must be bigger than 1. So what I'm going to do is, my best tip for sandwich Sudoku is to highlight the cells that can't be 1s and 9s in a different colour. Try and identify the cells that can't be 1s and 9s because it is so powerful in terms of solving. So if we trot around the grid here, given that M must be at most 9, 9 could be 2 plus 3 plus 4. It could be a maximum of 3 cells. So this is the furthest away the other 1 or 9 could be in this column. So those squares are definitely not 1s and 9s. In this column we have a 21 clue. 21 must be at least 3 cells because it must, you can't make 21 with 2 cells. Obviously 8 plus 7 is only 15. What else? Let's just try and pick off some easy wins if there are any. 29 here, that means we can't have 1s and 9s in the central 3 cells. And you can prove that to yourself. Like if we try a 1 here, the furthest away we could put the 9 would be here. That will require those 4 cells to equal 29. Well, if we add 8 plus 7 plus 6 plus 5 together, we only get 26. So you can immediately rule these 3 cells out. 31 is even more powerful than that. In fact, the 31 is forced now by this green cell because there can be a maximum of 1 cell here outside the sandwich filling. So if we think about why that is, we know that the row sums to 45. We know that 1 and 9 are 10. Plus 31 is 41. So we know there is exactly cells summing to 4 outside the sandwich. Now because you can't repeat the 1 in the row, the 4 must be a solitary digit, and therefore it's got to be here, look. So that square's a 1 or a 9, this square's a 1 or a 9, and now we are, to quote myself, cooking with gas, because this is going to complete column 1. Look, we can put in loads of green cells in row 4. The 6th clue here, well, we don't yet know quite what that looks like, but we can fill in all of those squares as green. What else can we do here? Let's have a look. There must now be a 1 or a 9 in one of these 2 squares, and that's quite powerful because, this is nice, yeah. So if we know that one of these 2 squares is a 1 or a 9, and we do because we need a second we've got this cell as a 1 or a 9, so the other one must be in one of these two sort of cells of the domino. We know that M is at most 9, so it's at most a 3-cell sandwich. So the furthest away that the other 1 or 9 could be here is actually that cell, because if it was this cell, that would be 1, 2, 3, 4 cells inside the sandwich. So we can actually green in all those. We know one of these two cells is a 1 or a 9, therefore this one isn't. And what else can we do? There must be one in one of those two squares, and there must be one in one of those 3 squares. So yeah, use colours. That's my big tip for sandwich Sudoku. It will do you great favours. Right. Now hang on. I should have spotted this straight away. Look, S is a 1 or a 9, and S is in James and it's in Charles. So we can repeat the 1 or the 9 up there. 12 must be at least 2 cells, so we can put those in green. Now again, this 12 clue is powerful, because let's have a think about whether this square can be green. If this square is green, the other 1 or 9 would have to be at least 4 cells away. And what's the minimum we could make 4 cells add up to? Well, 2 plus 3 plus 4 plus 5 is 14. That's too many. So actually, we know this square can't be green. It has to be a 1 or a 9. Finish off the greens in column 5. The 2 is interesting now, because 2 must be a single solitary 2. It must go in one of those 2 squares. Therefore, the 1, 9 is in one of those 2 squares, and this one is also green. Okay. So, where should we look next? Well, 27. Yeah, 27 is powerful as well, because we looked at 29. Well, 27 is not that dissimilar. Could this square be a 1 or a 9? Well, the furthest away we could put the other 1 or 9 is at the top of the grid. We'd have a 4-cell sandwich again. We know that the 4 cells add up to 26. 8 plus 7 plus 6 plus 5. That's not 27, that's 26. So this is not possible. Hang on, I just want to undo that. This square can't be, both of those squares can't be 1s and 9s. This square is a 1 or a 9. 15 must be 2 cells, look. Therefore, this square must be a 1 or a 9, because we can't place a 1 or a 9 in either of those 2 squares. I should have coloured them in. $12 we know is 2 at least, so we can place that. So A is not 1 or 9. And the 27 clue means that one of these squares in this domino must be a 1 or a 9, and therefore neither of those squares is a 1 or a 9. So now again we can place a domino up here again. Neither of those squares can be a 1 or a 9 because of the 4 clue, and in fact we can pencil 4s into one of those squares, so it's possible E is a 4, which would repeat down there. Now look at the 25 clue. This square simply has to be a 1 or a 9, because otherwise both of those squares would be a 1 or a 9, and that should have a 0 sandwich clue, not a 25 sandwich clue. So this square is a 1 or a 9. That means that one's green. And now we can't place the other 1 or 9 here. Why is that? Let's look at that. Well, it's because these squares would then have to sum to 25 plus 1 plus 9. That's 35, which would mean this square has to equal 10. Well, it can't. So that's why this square, therefore, is a 1 or a 9. That square is green. That square is green now, because if this is a 1 or a 9, this clue should be 0, and it's not. So that becomes a 1 or a 9 there. 19 must be at least 3 squares. So now we really are starting to get somewhere, I think. Place 1 or 9 here, make this one green. This square must be the 1 or the 9 in the box. It's the only white square left. That square's a 6 because of the sandwich clue. And what shall we do? Look, the 1s and 9s here now make that one green. Therefore, that's the last white square. That makes that one the 2. Oh, and we've got a 5 clue. So if we look at these two squares now, these two have to sum up to 5. We've got a 2 there. This is a 3, so the R is 3. James, I bet you didn't know that. Your R is equal to 3. Now, can we pick off anything else easy here? Yeah, we can. Look, the 4 clue's forced. So now this must be the 4. So your E is 4. There we go. Let's repeat the E down there. The M is 1 or 9. Well, the M can't be 1 because it's a sandwich. Ah, I see. So I see what Mark has done here. It's very clever. It's very clever. Now, I'm not going to fill this in yet because I want to show you why I think it's clever. So let's leave this in and just try and finish off the positions of the 1s and 9s if we can. So this square can't be a 1 or a 9 because of the 19 clue. Therefore, this is a 1 or a 9 here. 29 clue could be a single 6 outside the sum, or could be a 2 and a 4. Ah, but this 6 tells us the order, look, because of this 4. Now, if this square here was a 1 or 9, these two squares would have to sum up to 6 without using 1, 5 and without using 2, 4. Well, that's not possible. So actually, we know this square is not a 1 or a 9. It must be green. This square is the last 1 or 9, which makes this square a 6. That square now is the last position for the 1s and 9s in the box. That must be a 6 over there as well. That places a 6 in one of these two squares. I mean, actually, let's just no, actually, I want to come back to these 1s and 9s before I complicate things. Let us stare at this grid now. All the 1s and 9s are sort of in position, but we haven't disambiguated the order of them. And if you're doing a normal sandwich Sudoku, which doesn't have James Charles written in it, and you reach this position, the puzzle's actually broken, because there's no way of telling which way round the 1s and the 9s go. That's why if you look at any standard sandwich Sudoku, you will always see a 1 or a 9 amongst the givens, or both. It's to avoid this pattern, because let's imagine, you know, that was a 1, that was a 9, that was a 1, that was a 9. And let's just focus on these boxes and ignore we've got James sort of intermediating here. What's to stop us from just changing all of these, both of those 1s to 9s, both of these 9s to 1s? What changed as a result of me doing that? Did any of the sandwich totals change? No. Did the numbers of 1s and 9s in this box or this box change? No. Did the numbers of 1s and 9s in this row change? And they wouldn't change, obviously, if you changed all the 1s and 9s in the rows and the columns either. So this is why there is a problem with this pattern if you can't find a way to disambiguate at least one of the 1s and 9s. And Mark has done it very cunningly using the M of James. Because by making sure that this clue here, we know it's a 1 or a 9 now. We know it can't be a 1 because it's 2 digits long and you can't put a 1 inside the sandwich. So this has to be a 9. And once it's a 9, what's going to happen? That is going to propagate right round the grid here like this and fix the order of everything. And now we don't have a puzzle with 2 solutions. We have a puzzle with just 1 solution, hopefully, assuming I can do the rest of it. And there we go. So this M is very important in combination with this M here. Let's tidy up some of the pencil marking. Those two like that, and see if we can finish this off now. So let's look at the columns. We've got 21 here, so these cells sum to 21. The 9 and the 1 give us 31. The whole column sums to 45, so this has to sum to 14. without using 9. So that's 6 and 8. And there's a 6 there actually, so it's 6 and 8 in that order. There's a 6 over here. Now there's a 4 in one of those two squares. M is 9, isn't it? So okay, so it's M is 2, well, M is 9, but these two cells are 2 and 7 because they can't be 4 and 5, 1 and 8, or 3 and 6. So that's 2, 7 into those two squares, which places a 2 in one of those two squares by Sudoku, look. 2 in one of those two squares. We've done the 5 clue, we've not done the 12 clue, and we don't yet know, I think, how to do the 12 clue. We know there's a 4 down there. 27. The 27 clue's fixed now, look. Well, when I say it's fixed, the outies are fixed. These two cells are fixed because we know these add up to 8. Where am I getting 8 from? Well, 45 minus 1 minus 9 is 35, minus the sandwich filling, so minus 27 gives us 8. So these two squares have to add up to 8. We can't use 1, 7. We can't use 2, 6. Therefore, they are 3 and 5. These 3 squares add up to 12. Don't know what they are yet. These add up to 9, isn't it? We don't, but we can't work out what they are in this instance. So we've sort of used the columns, it feels to me, at least at this stage. Let's use the rows now. We've done that one. I looked at this briefly before and then got distracted with the 1s and 9s. Look, there's a 6 in this total. So that means this total here of 19 is made up of 6 plus 2 more digits that must add up to 13. But we can't use 4 and 9 to make 13, and we can't repeat the 6. We can't use 6 and 7. So actually these 3 squares must be 5, 6, 8. And why does that matter? Well, I can see it matters from our pencil marking. That square is not 4, therefore this is 4. That's not 6. One of those two squares must be 4. 5, 6, 8 means this is a 3 and this is a 5. There's probably more we can do there, but let's carry on looking along the rows. These add up to 15, but we don't really have any restriction on that yet, apart from it doesn't involve a 2. The 2 we've done, the 35 we've done, the 6 we've done, 19. 19 here involving a 4. Well, that's got to be 4, 7, 8 then. That's the only way of doing that. Okay, so this 8 and these 8s mean that these two squares now are 6 and 8. So C is a 6 or an 8. L is a 2 or a 7. These two squares here have got to be 2 and 5. Beautiful. So look, the A is a 2 or a 5, but over here it can't be a 5 because that will clash. So A is 2. That comes back over there. That means the H is a 5. These 2's mean that's a 2 up there. That means that's a 2. That's a 2. Can we go further? So now we've got all the repeated digits. Look, the A, the E and the S we've sorted out. This 2 fixes that the L is a 7. That's a 2 down there. That's a 2 there. I think we've done all the 2's now. It felt like that flurry of 2's was about how many we needed. These two squares have got to be 3 and 5, and indeed that one as well. So let's pencil those in and see what we can see. So let's go back to the columns now and check what we've got. Have we used everything? 21. We've done the M. We've done that one. We've still got the 12 to. We've still got this 12 to figure out. That's not budged at all. The 25 has budged though. Why is it budged? Because we know that outies sum to 10, and now we've got a 2. So that square's got to be an 8 in order to make the outies add to 10. Does that help? A little bit, but nothing major. The 27 we've done. Now in the 12 clue we've got a 2 now. So these two squares have got to sum up to 10. without using 1, 9 or 2, 8. So we're looking at 3 and 7, which would have to be this way round, or 4 and 6, which would have to be this way round. So that becomes a 4 or a 7, which we already actually knew it was a 4 or a 7 just looking at the row, so that's completely unhelpful. J is equal to 8, because just to complete this box. Okay, well that's good. Now M we know is a 9, so these two squares now can't be 1, 8, 2, 7 or 3, 6, so they have to be 4, 5, which means that is a 7, that's a 4, therefore that's a 6. That fixes our 6 and 8 down here, locks an 8 into one of those squares. Now if we look at that, that's got to be a 3 to complete column 1. That fixes the 3 and the 5 over on that side, fixes the 5 here. Those two squares are 4 and 7. We can do that as well, look. That fixes a 7 over there, so that becomes a 7, 8. That's got to be a 3. Okay, so we could look at this 15 clue, I guess. Is that going to be the easy win here? We've got the 15 clue, we've got the 12 clue, 21 clue, 25 clue we've done that one, we've done that one, done this one, and we've got quite a lot of digits in this one. Let's have a look at this, 3, 5 and 7. It's not brilliant. That one can't be 3, that one can't be 7. That one can be anything. These three squares, that's where we should look now, probably, isn't it? 3, 6 and 7 into those squares. That one can't be 3, but that means those ones have got to be 4, 5 and 8. We've got a 4 there, so that is nice. That gives us a 4, gives us a 4, gives us a 5. 5 must be in one of those two positions. More importantly, it disambiguates this 15. Look, that is the key to this 4. Because now, how do we make those two squares add up to 11? The only option that's going to work is that that's 3 and that's 8. So that's lovely. 3, 8, 7, 7, 6 into those squares. Now this must be the 5. It's the only place the 5 can go in the row. That becomes an 8. That can't be 5 anymore. That's got to be 7 because it can't be 3. That's 3. That's 5. That's 7. That's 8. I hope I'm not making any mistakes here. Get rid of the 8s there. 5 and 6, still don't know. The 4 tells us the 4 and the 7 at the bottom though. And the 12 is going to disambiguate everything, isn't it? Because this has to be 8 now. That's got to be 5. The 5 and the 6 must be in this order. 8 must hide away in the corner there. That's a 3. That's a 3. And if I haven't made any errors, that should be a 6. There we go. Let's see. There we are. Yes. That's how to do James Charles's own sandwich Sudoku. I hope you enjoyed that. Yeah, I mean, and as again, thank you, James. From me in the solve and from Mark in the setting of this puzzle. Very cool. We'll be back later with another edition of Cracking the Cryptic.